Welcome to The Explainer. I'm absolutely thrilled to dig into this with you today because the data reveals a truly fascinating journey. We're going to explore what's called the AI maturity curve. We'll look at how you can scale up your back-office workflows, discover some brilliant hacks to drastically slash your LLM token costs, and finally, we'll talk about deploying completely autonomous voice agents. Let's find out how this integration actually comes together in the real world.
Okay, let's dive straight into this. Be honest for a second. Are you currently burning through your Claude token limits before lunch without even realizing where they went? Or maybe you're hopping off intense sales calls and still wasting hours doing the manual, incredibly repetitive back-office task of typing out client proposals? If that sounds familiar, you are definitely not alone. But you are leaving a massive amount of time and money on the table.
So here is our roadmap for today. We're going to walk step by step through the AI maturity curve, automating complex client proposals, stopping AI context rot, hacks to slash token costs, and finally, building advanced voice agents. Let's get started.
Part 1. Automating complex client proposals. Imagine this. You just hopped off a discovery call, and within a few minutes, a highly accurate, fully realized slide deck proposal is just waiting for your review. Well, here's exactly how this end-to-end pipeline makes that happen. First, a webhook listens for a completed meeting in Fireflies. But we don't just grab the transcript immediately. The pipeline actually uses a polling loop to wait until Firefly's native AI finishes generating its summary and gist. Once that data is cooked and ready, we pass the raw JSON to a code node, which, by the way, you can just have Claude write for you, to clean up the transcript and extract the speakers. Then a Slack notification pings you for human approval. If you click yes, an AI agent takes that beautifully clean transcript, applies a strict system prompt to format a business proposal, and shoots off an API call to Gamma to generate a polished slide deck. It's like magic.
Now, as you build out these workflows, you'll start to realize something absolutely crucial. Code beats clicks. Think about it. If your workflow gets triggered naturally by a meeting ending, well, that's one path. But what if you want to manually trigger it via a form submission later on? Instead of duplicating the entire process, you can use dynamic set nodes to standardize your inputs, things like the meeting ID and the transcript. This ensures that no matter how the workflow actually starts, the AI agent down the line always knows exactly which variables to reference. Honestly, it's infinitely more scalable than relying on a basic graphic user interface.
Moving right along to Part 2. Stopping AI context rot.
Now, what's incredibly fascinating and a bit scary is what happens once you start relying heavily on these AI agents. You really have to manage your token limits efficiently so your models stay sharp. Take a look at this staggering statistic. One developer analyzed a massive 100-plus message chat session and found that 98.5% of all tokens consumed were spent just rereading the old chat history. Every single time you send a prompt, the AI rereads the entire conversation. It isn't a linear cost, it's exponential compounding. So message 1 might only cost you 500 tokens, but message 30 could cost you 15,000 tokens just to hit send.
And this exponential compounding leads directly to a massive problem we call context rot. Think of it almost like AI dementia. As the model's working memory fills up with old tool outputs, failed code attempts, and just massive text files, its attention gets spread way too thin. It literally starts to forget your initial instructions, gets easily distracted, and even begins contradicting itself. Your model essentially becomes significantly worse at reasoning, all while charging you vastly more money per prompt.
So how do we actually fix this? Well, Claude does have a built-in feature called auto-compaction, but the catch is it doesn't trigger until your context window is about 95% full, and by that point, your context is already deeply degraded. The real pro-level strategy here is manual compaction. You want to take control of your context window when you're only about 60% full. At that point, have the AI summarize the session, clear the history, feed that neat little summary back into a totally fresh session, and just continue working.
To really drill this point home, I want you to remember this phrase. Auto-compaction at 95% is like frantically packing a suitcase 5 minutes before your flight. If you let the system automatically compact at its absolute least intelligent point when context rot is at its absolute peak, you are basically guaranteed to lose vital project details and logic. You've got to pack your bags early, when the model's head is still clear.
All right, Part 3. Hacks to slash token costs.
Let's hit some rapid-fire developer strategies to drastically reduce all that token waste we just talked about. First up, disconnect any unused MCP servers. These are the protocols connecting your AI to outside tools. Every active server loads all of its tool definitions into every single prompt you send, which drains invisible tokens fast. Second, utilize the Google Workspace CLI or command line interface. A CLI is JSON first and is vastly more token efficient than traditional servers for basic tasks like reading docs or scheduling meetings. Third, strictly keep your Claude.md system prompt under 200 lines. Keep it tight. Fourth, always use plan mode before tasks so the AI doesn't write hundreds of lines of the wrong code. And fifth, forcefully clear context between unrelated tasks. You definitely don't want to carry Project A's history over into Project B.
You have to make the invisible visible. Turn on your status line in the terminal and start using these commands. Use context to see exactly what is eating up your capacity right at this second. Use compact to manually clean up the chat, just like we discussed earlier. And perhaps most powerfully, use re to rewind. If Claude makes a mistake, don't just say, hey, try again. That failed attempt is going to pollute your context forever. Instead, use re to jump back, drop that bad history entirely, and try a new approach with a totally clean slate.
And this brilliantly illustrates exactly why this discipline matters so much, even if you're working with a massive context window. The data shows that retrieval accuracy in a 256K token window sits at a very healthy 92%. But if you bloat that window all the way up to 1 million tokens, the accuracy actually drops to 78%. Just because you have a 1 million token limit doesn't mean you should ever try to fill it. Treat the window as insurance, not a goal.
Finally, part 4. Building advanced voice agents.
Okay, now that we've totally mastered our back-office workflows and hyper-optimized our AI engine, let's talk about deploying autonomous, front-facing voice agents using 11 Labs and Claude Code. Let's deconstruct this voice agent loop. It basically consists of 4 core mechanics. First, you have the persona. This is your system prompt dictating exactly how the agent behaves. Maybe it's a warm B2B sales tone or a highly technical support guide. Next is the voice, where you can deploy a remarkably realistic professional voice clone. Third is knowledge, which is grounding the agent in specific documents or even your entire library of YouTube transcripts. And finally, tools. This gives the agent the ability to execute API calls, like syncing with cal.com, so it can actually book meetings directly onto your calendar in real time.
Now, let's see how this builds out. Traditionally, setting all of this up would require you to click through dozens of clunky GUI menus and read endless API docs. But by using Claude Code right inside a VS Code terminal, you can just speak your requirements in plain, natural language. Seriously. At minute 0, you just explain your goal. By minute 5, you're simply dropping in your cal.com and 11 Labs API keys. By minute 10, Claude has read the documentation and completely configured the calendar tools for you. And by minute 15, Claude outputs the exact HTML snippet you need to embed a live, fully working voice widget directly onto your website. It is just blazing fast.
But hold on, the crucial point here is that with this kind of power comes responsibility. When you embed a widget on your site, literally anyone can talk to it, and that eats directly into your 11 Labs credits. You absolutely must secure the perimeter. First, lock down your widget hostnames. If you don't, someone could easily inspect your site's code, steal the widget, and embed it on their own site just to drain your budget. Second, be sure to set conversational caps, like a maximum minute duration per call. This serves as an ironclad budget guardrail against any malicious overuse.
Wow, we have covered massive ground today exploring these sources, from automating those tedious client proposals all the way to deploying a functioning voice agent in literally 15 minutes. The tools to do this are sitting right there in your terminal waiting for you. So here's my question. What does this all mean for you? Which part of your workflow will you automate first to master the AI maturity curve? Thanks so much for exploring this with me on The Explainer today, and I'll catch you on the next one.